This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. For hundreds of years, longtime residents and infrequent visitors alike have known about the mysterious slime that rises in the waters of the northern Adriatic Sea. In strange episodes first documented in 1729, the region has regularly suffered outbreaks of mucilage, a sticky whitish-green slime that coats sea surface waters, much to the disgust of recreational swimmers. Although mucilage is not thought to be harmful, severe events occurred in 1989, 1997, and 2000, dampening the region's lively tourist industry. While scientists are not certain what's behind the phenomenon, recent efforts are beginning to provide clues. Farouk Azam, a distinguished professor in the Marine Biology Research Division at Scripps Institution of Oceanography at UC San Diego, and members of his laboratory have been studying the roots of mucilage events at the microscopic scale. Azam's graduate student, Francesca Malfatti, knows all too well about the slime. She grew up in the Italian city of Trieste and has vivid childhood memories of mucilage outbreaks. She is now applying her training as a microbiologist and new technological tools to study the molecular origins of mucilage, decipher its structure, and probe the ecological conditions that give rise to mucilage events. Azam and Malfatti's results could provide a new understanding of the mysterious goo and much more. Their research could uncover new insight into the importance of tiny microscopic worlds and how the vital processes they underlie carry consequences across the global oceans.
My name is Francesca Malfatti. I am a sixth-year graduate student in the Azam lab, and I come from Trieste, a city on the Adriatic coast of Italy. Since I grew up in Trieste, from summer to summer there was this event in the sea happening, the mucilage. So if you live on the coast of the Adriatic Sea, you know it since you are born. Mucilage in the sea looks like a gel, a mucus floating on the surface when reaches the surface. Can be color from yellow to green to brownish, and usually happens during the summer. And so living in a coastal city with the desire to jump in the water, it's pretty disgusting when you are jumping in the mucus.
What causes the mucilage outbreaks has been a mystery, but Malfatti, Azam, and their international team of colleagues from Italy, Slovenia, and Croatia are starting to put the pieces together.
We don't really know the complete story. What we do know, and so the ideas that we have that we are testing, part of it is due to pollution. There's a huge river that runs into the northern Adriatic Sea. It's called Po River. It brings huge amounts of nitrogen and phosphorus, mainly left over from agriculture upstream. It creates blooms of algae, these microscopic algae. So you have normally blooms of algae produced in many, many different places, but these are persistent blooms, especially in the northwest side of northern Adriatic Sea.
Azam believes that the algae blooms produce organic matter that bacteria cannot decompose fast enough, leading to the globs of slime. To gain a greater understanding of what's happening, Azam and Malfatti are using new technologies to study the processes at the microscopic level.
One thing that we are using is called atomic force microscope. What it does is that it can essentially feel the architecture, ups and downs of the architecture of the macromolecules that mesh together to create this world in which microbes live, interact, and die.
So far, with the atomic force microscope imaging the mucus, we had a better understanding of the structures of the mucilage and their relationship with the bacteria.
Beyond the technological prowess of his new instruments, Azam believes the new insights they help provide will pave the way for a better understanding of microbes and their importance across the entire ocean ecosystem.
So these fancier tools and very powerful tools that we are using, so they are becoming more important as we begin to realize that it is necessary for us to gain a deeper understanding of the microscopic world in the sea, especially as we now begin to pay more and more attention as a society on the role of the ocean's life in carbon cycle, role of the ocean's life in response to the ocean to global warming. So there are these huge environmental challenges that, when it comes to the ocean's role, really boil down to the activities of the microbes.
This has been a presentation of Scripps Institution of Oceanography at UC San Diego.